Uh, Hello everyone. My name is Yash, and I'm someone. And if you have been watching, which you haven't, not a whole lot of people are watching, but I'm someone who is interested in learning data science. Never got around to it. Not necessarily never got around to it, but you know never built any consistency with it. And I would study for a couple of days or a day or two, and then something would happen, or like even my laziness or my procrastination, I wouldn't do it. Sometimes certain situations in life happened, certain situations in my family happened, certain health concerns with certain family members. uh, so the for variety of reasons, a lot, some of which are definitely my fault, never got around to it. So these videos, these streams, these are a way to hold myself accountable, but more than that, just build some consistency. So we can just get my ass on a seat and just get myself in front of my laptop and just go for hours on end. So these streams are a way to do achieve that. But more than anything else, I thought, I can't be the only one who's struggling with laziness, procrastination, something happening. So you know who should watch this video, who should be watching this stream. If you are someone who is interested in learning, never got around to it, you can watch me learn, and maybe you will do better than me. And anyone else who could be watching, maybe you are someone who likes watching other people struggle. If you like watching other people make a fool of themselves trying to learn, because that will happen. I will be trying to learn stuff that I don't have a lot of ideas about. So I will make some stupid mistakes during the course of these videos, really. So if you enjoy watching that, you should be watching. So let's get started. Last video we covered. No, we didn't cover. We started with joins, and we got the basics of it. I will go over it once again, just for the sake of, if you are one, if you, I hopefully I get some first time viewers. But if I do get them, just for that, I will go through what we went through. We went through joins, which basically means when you have a database of multiple tables, and two tables share data, a common table, a common which has common data values. So to join them for making a more comprehensive result, that's where joins come in. So we will cover it. We are going through this Udemy course. Okay. So we will go through this inner join first. We know what as a statement is. As a statement is when you want to bring up a set of data, a column really, and you want to name it something else, because you want to name it something that is more presentable. That's when as is used.
Of that Venn diagram, stuff that's both in because we're only looking at the intersection of that. There are several types of joins, and in this lecture, we're going to go through what I think is the simplest join type, which is an inner join. And typically, when students are learning about joins in SQL, they always start off with the inner join because it's the easiest to understand. First off, what actually is a join operation? Put simply, joins allow us to combine multiple tables together. Now, the main reason for the different join types is to decide how to deal with information only present in one of the joined tables. So let's begin by imagining a very simple example. Let's say our company is holding a conference for people in the movie rental industry. So before the conference actually starts, we're going to have people register online beforehand. And the registration is simply just providing their name, and we'll keep track of people as they register. And then the actual day of the conference, they're going to come in and log in.
You know what? If the point of these streams is making mistakes and learning from our mistakes, then we shouldn't be scared of making mistakes. Let's see if I can get this right. All right. So if I remember this right, let's see if I do. Select. I already started. I'm already fucking up here. Okay, so if we select customer ID from if we select customer ID from customers and we select payment ID customer. So basically, if you don't know anything about it, it's not like you and I know that much. I know that much more than you. I don't. But if we have to join this, yeah. Inner join. Let's see. Customer dot customer ID. Yeah, I don't think I remember all of it. Let's see. Well, the most that will happen is I won't remember. And yeah, no. I know
And
this
through
is
an
not
iPad
right.
with their name. Inner join is essentially symmetrical, which means if you
Oh yeah. Instead of and, it would be this. Payment dot customer ID. Oh yeah. Inner join payment on. Let's see, it still doesn't work. Okay. It's not ambiguous. What the fuck? Let's see if it works this time. It still didn't work. Let's see. Let's see what we did wrong. Okay. Let's go to Chat GPT. What do you think is wrong with what I wrote? This is the error that is showing. Okay, so that's what it wants. So this is what we need to do. Okay. So this is like the easiest apparently. We can do tricky. I like my mind does go to doing some tricky stuff with this, but like you know what, white as well do it. Why am it's not like we. Let's see, payment also has amount, right? So let's go with amount and let's add group by amount. It didn't work. What is the problem? Okay, let's see what is wrong with this. This will throw in error because you without properly aggregating the non. Okay. issue. You're selecting customer in select clause without including them in the group by clause or applying to them. Rules because it cannot determine which customer is to include. Decide the intent. If we go to amount and okay. Okay, let's go with this. Okay. Looks like we flew too close to the sun. I'm likely biting more than I can chew right now. But we will get back to this. I have some ideas of how this can be used, but as we can see,
Select from table A and then inner join table B to look like this. Select from table B, inner join on table A, you would get the same result. So getting from table A and then joining on table B is the same as getting from table B and then inner joining on table A. Keep in mind, this is only true for an inner join in this particular case. So switching around the orders here, even switching around the column, same regardless, because this is a symmetrical Venn diagram. So let's actually work through this and what would actually happen in a more realistic situation with the example tables. Here, we're going to say, select all the columns from registrations, inner join logins. So that's essentially saying, take registrations table and then PostgreSQL will treat it as an inner join. Now, I'd highly recommend that you always type out the full inner join, but some people, as they get really used to PostgreSQL, just use the shorthand of join, which defaults to inner join. Okay, let's go ahead and jump to pgadmin and work through a couple of examples. Okay, here we are in pgadmin. Now, if we come over here to schemas, under public, under tables, we can see the various columns that are in the tables. So if we take a look at, for example, the customer table, we can expand the columns, and we can see we have the customer ID, and then the associated information with that, such as store ID, first name, last name, email, etc. And we can see in the payment table, we have the payments, as well as a specific payment ID, and then the customer ID. So what I want to begin exploring is if there was a way I could join the payment table with the customer table in order to get maybe the customer email associated with a specific payment. So for example, I can say, select everything from payments. We'll go ahead and run that. Let's put this on two lines together, just for readability. So I run this and I can see I have a payment ID and then a customer ID, staff ID, rental ID, amount, etc. Let's go ahead and do the following. We'll say, select everything from payment, and we'll perform an inner join with the customer table. So this is essentially table A inner joined with table B. And since I'm doing an inner join, I'm only going to get back results where that particular customer happens to be both in the payment table and in the customer table. And now I have to decide what I'm actually going to join them on. So I have to join them on a column that is associated with both the payment table and the customer table. And I can see I have this customer ID column, which essentially uniquely identifies every single customer. So let's go ahead and join it on, and then we'll say payments dot customer underscore ID equal to the customer table dot customer ID. And if we run this, we should get back a lot of columns. So we run this, and we can expand on this. And now you'll see I have the payment ID, customer ID, essentially all the information from the original payment table. But if I keep going further, now I see the repeated information based off customer ID, but now it's on the customer table. So I see the store ID, first name, last name, email, address, etc. All right, now let's see how we can select certain columns from each table. If I'm referring to a column that can only be found in one of the tables, then I don't need to specify what table it should come from. Luckily, PostgreSQL is smart enough to understand that if I refer to something such as select the payment ID column, since that's only found in the payment table, I don't need to actually clarify what table it should come from. However, if I'm referring to something like customer underscore ID, that can be found in both tables. So I should clarify what table I'm actually asking the customer ID from. And since I'm asking for payment ID, I should probably link.
We get the idea of what this is. Let's go to the fuller outer join. I don't have any idea what it is and what it isn't.
Now let's review the two example. So in this series of lectures, we're going to start by talking about full outer joins, which is the simplest outer join, and we'll also add in the clarifying where statements you can add in order to specify what actual rows you want even further. And then we'll go into a lot of detail about the left outer join, which is probably the hardest for beginners to grasp. And then we'll also add in clarifying where statements to subselect rows from a left outer join. Once you understand that, we'll just quickly go over right outer join, since it's essentially the reverse of a left outer join. And if you understand a left outer join, you pretty much already understand a right outer join. It's just the opposite. But let's not get too carried away. Let's begin with the full outer join. So let's start with the full outer join. Now let's review the two example tables from the previous lecture series on inner joins. Recall we have these registrations tables and this logins table, where we have people registering for a conference, and then depending on whether or not they showed up or if they registered, we have them log in on site. Here we have Andrew, Bob, Charlie, and David, or ABCD. They registered. Logins, Andrew and Bob show up. They're present in both tables. However, we have Xavier and Yolanda. They forgot to register, but they still showed up and logged in anyways. Okay. So we know we would join these tables together on the name column. Again, in this little universe, we're going to assume that the name is a unique identifier. There's no such thing as two Andrews or two Bobs in the world. And recall, using that inner join that we learned about previously, we could match Andrew and Bob in both tables. However, keep in mind we have names that only appear in one table, and that is Charlie and David in registrations and Xavier and Yolanda in logins. So let's see how the different outer joins deal with this particular discrepancy. We're first going to take a look at the simplest, which is a full outer join. And this actually might be even easier to understand than an inner join. So an outer join, or a full outer join, just grabs everything. So the syntax is select all the columns from table A, do a full outer join of table B, and then on wherever that column match occurs from table A equal to table B dot column match. And it's essentially just grab everything, whether it's present in both tables or present in only one table. Notice that it doesn't really matter again if table B and table A order is switched here, because this is completely symmetrical. So because this Venn diagram is symmetrical, you can switch off the table order because you're going to grab everything anyways. So let's take a look at this. The actual syntax here would be select all the columns from registrations, perform a full outer join on logins on registrations.name equal to logins.name. So let's actually see how SQL thinks about this in the background. First, we're saying grab everything from the registrations table. So I'm going to have to first make this just font-wise a little smaller so we can fit in the results table. And we're going to fill in the results table the way we can think about this. We're saying grab everything from registrations and a full outer join on logins. So we fill in first everything from registrations. Again, we don't really need to worry whether or not they're in table B or table logins because we're grabbing everything anyways. So we fill in with Andrew, Bob, Charlie, and David. And then we're doing a full outer join on logins, so we need to start filling information for where we actually have a name match. And we know we have a name match on Andrew and Bob, and then we fill it in with the corresponding login ID. In this case, it was number 2 and number 4. Now the issue we arise with is that we didn't have a Charlie or David in logins, but we're still asking for everything. So what SQL ends up automatically doing for us is filling this in with null, essentially clarifying to you that there was no value there present. So there was no Charlie or David in the logins column. And since this is a full outer join on logins, we also need to fill in the rest of logins, which was Xavier and Yolanda, and then the corresponding null values for the registrations table because they were only present in the logins table. So this is what it would look like to do a full outer join on these two tables on the name column. We grab everything and then fill in for null values where we only had a row present in one particular table. So this is the easiest outer join to understand because you're essentially just grabbing everything. Now the next thing I want to quickly discuss is qualifying a full outer join with a where statement. And we can do this in order to get rows unique to either table. In other words, rows that are not found in both tables. Essentially, this is the exact opposite of an inner join. Let me show you why. The way this works is we say the following. We'll say select everything from table A with a full outer join on table B on table A.column match is equal to table B.column match. That's what we had last time, and that filled in the entire Venn diagram, including the intersection. However, we're going to add in a where statement to qualify it a little further. And this is going to add in the statement where table A.id column is null or table B.id column is null. So that essentially means that we're looking for the actual values where one of the tables ID columns is null or the other table's ID column is null. Essentially the opposite of an inner join because this will only grab things that are unique either complete to the table A or unique to table B. Keep in mind, notice here I could have switched the order from table A to table B because this is again symmetrical right down the middle. So what does this actually look like in our example? We'll say something like select everything from registrations, a full outer join on logins, on registrations.name equal to logins.name, and then we can specify where registrations.this registration ID is null or where logins.login ID is null.
Select film is it like is full? Oh, this is the problem. Full outer join fill outer join inventory wait a second. Um, on let's see. Film ID dot film equal to inventory id dot inventory. By the way, this habit of printing the whole thing, this is not like actually a good habit. This is just convenient right now. You should be you should be dragging and dropping thing. That's apparently that's the right habit. That's what I heard anyway. Full, oh, sorry. Full outer join what happened? Missing from clause entry for table film ID. Huh? What? Missing from. Okay. What is wrong with this query? There are several. That is bullshit. Oh no, that isn't. Let's see. We got it. Yeah, we got it. Okay, so we got it this time around. Okay. So this is what I meant when I said I will make an idiot of myself all the time. This is going to happen. There's no way around this.
So this to show you how this would actually
I do
work.
it so you don't have to. All right? Yeah. I'm doing all of you a favor. I'm making an idiot of myself so you don't have to.
This is what we had last time. This is a full outer join. And notice here we have null values for our registration ID and null values for our log ID. Technically, we could have done the checking of null on name as well, but we're just going to use the ID column here. And what we're going to do here is we'll specify grab them where there's only null values for that. So look here, we're going to add in where registrations.regid is null or where logins.logid is null. Essentially, you can think of this as adding an where statement after you've already done the join. So you're just further filtering. You're going from this full outer join table and then specifying find me where those ID columns are null. And that essentially removes those first two rows, which was the match for Andrew and Bob. And now this is going to show us the results that are.
Okay, we didn't even did we get any null values? Where is null or is null. Let's just make sure that yeah. Okay, let's see. Okay, so there are 5 values where there are a lot of nulls. Okay.
Unique to only table A or only table B. We no longer have rows that can be found in both tables. Essentially, the exact opposite of an inner join. So let's see a quick example in pgadmin of full outer joins, as well as adding in that qualifier. Okay, here we are at pgadmin. Let's imagine that some new privacy rules have been implemented, and we want to make sure that we don't have any payment information that's not attached to customer, or that we don't have some customer information that isn't attached to any payments. Essentially, we want to make sure that all the payments we have is associated with a current customer, and all the customers we have are associated with some historical payment. We don't want to have some customer ID information for someone that's actually never purchased anything in any of our rental stores. So that's the new privacy update. We're just kind of imagining the situation. So what are we actually going to do here? We can say select everything from payment just to get an idea of what we're working with. We have, again, this payment ID and this customer ID. And I want to make sure that essentially all the payments here are associated with a current customer, and if I select everything from customer, that these unique customers are associated with some sort of payment. I don't want to have any customer here that hasn't actually made a historical payment. So the way I'm going to do that is I'll say select everything from customer and do a full outer join with payments. And just as before, we're going to say on. We'll say customer ID equal to payment dot customer ID. So because this is a full outer join that's just going to take everything and join it together. So essentially, this is every single row found in every single table. So again, it's everything from customer and everything from payment. But recall the new privacy idea that we wanted to implement was to figure out, make sure we don't have any information that's essentially unique to payment, not associated with customer, or unique to customer, or we for some reason have customer information like their email when they've never done a historical payment. So that means I want to perform an additional filter with a where statement. So I want to check where on my customer table that customer ID happens to be null. So we'll say where customer ID is null. We can put that in lowercase. Or where payment ID is null. All lowercase there. So what is this actually saying? It means we're going to fully join the customer table and the payment table where those customer IDs join up. And now I'm going to filter it to attempt to find rows that are either only unique to the customer table, meaning we have information about a customer that's never made a payment, or only unique to the payment table. Notice here how I'm using the payment ID, which is a unique identifier for the payment table. If we keep going over, we can see here every single payment has this unique payment ID. And if I run this, notice I get back empty results, which actually means we're in compliance with this new privacy policy. We don't have any payment information not associated with some customer, and we also, more importantly, don't have any customer's email information, their first name or last name, who has never made a payment. Now, what's another way we could confirm this? Well, I could confirm this by taking a look at the distinct customer IDs in both a customer table and my payment table. So this alone basically tells us that there are no rows that are completely unique. Essentially, there are no customer IDs that are completely unique only to the customer table or only to the payment table. If we have information on a customer, it's because they've done some payment in the past. And we're able to select this with a full outer join and then filtering to make sure that there wasn't anything unique only to one of those tables. And to confirm this, just so we can wrap our head around this idea, let's go ahead and just count the distinct customer IDs from the payment table. So if I run this, there's 599 unique customer IDs or distinct customer IDs in my payment table. And if I take a look at my customer table, refresh this, there is also 599 distinct customer IDs. Now, technically, this doesn't fully answer the previous privacy compliance policy because there could possibly be different ID numbers in different tables. The real way to answer the previous question, to make sure there wasn't any customer information that didn't have payment information, was using that full outer join and then filtering an additional where with the null null statements on those unique identifiers for the customer ID and payment ID. This technically by itself only further validates that last query we did, but doesn't actually fully answer the question. Because technically there could have been maybe customer IDs that were letters in one table that were 599 unique letters, or a series of letters, and then the other table could have 599 unique numbers. So keep that in mind. While this does clarify and verify what we did, it doesn't 100% confirm that privacy policy. The only way to do that was using that full outer join with the additional where.
Now we will learn about left outer.
Welcome everyone to this lecture on the left outer join, otherwise known simply as just a left join. A left outer join results in the set of records that are in the left table. If there is no match with the right table, then those results are null. Later on, we will learn how to add where statements to further modify a left outer join. So, what does a left outer join actually look like? Here, notice that our Venn diagram is no longer symmetrical, which means the order will actually matter. Here we're saying select everything from table A and do a left outer join on table B. The left-hand table is the first table referred to in that from statement. So that's why table A there is seen on the left. So we're saying select everything from table A left outer join on table B. On table A.columnMatch is equal to table B.columnMatch. So notice we're essentially just grabbing information from table A where there's either exclusive to table A or table A has a match with something in table B. If something is only found in table B, then it is not going to be returned in the query. And again, recall that a left outer join can be shortened to just left join in SQL syntax. So it doesn't matter if you use left join or left outer join. Now, because of this asymmetry, this is where beginning students often get confused. Previously, everything we saw, it was symmetrical in that Venn diagram, which means the table order didn't matter. When it comes to a left outer join or a left join, the order does matter because we have to actually specify what the left table is going to be. So notice here we're saying table A, which means we're going to grab things that are exclusive to table A or can be found in both table A and table B. We're not going to be returning anything exclusive to table B. So again, not returning anything exclusive to table B. So let's explore a left outer join with our two example tables. Here we have registrations and logins. So what we're going to say here is say select everything from registrations, perform a left outer join on logins on registrations.name equal to logins.name. And what does this actually look like? Well, it's going to return the following. Recall that we're going to grab everything from the registrations table, and if there happens to be a match with the logins table, we'll go ahead and return it. If there is no match, we're still going to grab that information from the left-hand table, which is from registrations, but because there's nothing in table B for it, we're going to fill it in with null. Notice that things that were exclusive to the right-hand table, that is the logins table or table B, that was Xavier and Yolanda, we don't actually see them in this result of the left outer join. Previously, when we saw a full outer join, we did see those results. But now, because we're specifying a left outer join, we only see things based on that left-hand registrations table. It either belongs to both tables or only to registrations. If it only belonged to logins, we don't see it returned here. So again, everything from registrations ends up showing up in this left outer join, which is why it's critical to remember that table order does matter in the SQL query syntax when it comes to a left outer join or a left join. Now we can further qualify. Remember that table order does matter in the SQL query syntax.
Let's see. Let's see.
When it comes to a left outer join or a left join. Now we can further qualify this with a where statement to get rows unique only to the left.
Wait a second. I got wrong with the shit.
Table. So, for instance, what if we only wanted entries unique to table A? Those are rows found in table A and not found in table B. So we're essentially just grabbing rows unique to table table A not found in this other table. So the way we do that is by saying the following. We're going to again select from table A, do a left outer join on table B, specify the column to match on, and then we're going to say where table B is null. Because if table B is null, that means the resulting rows would only be unique to table A. So
we did this, right? Wait a minute.
is null.
What the fuck? I just had a rat. What the fuck?
Because if table B is null, that means the resulting rows would only be unique to table A. So, recall this was our previous query. This is just the left outer join, registrations and logins. And what we're going to do here is if we take a look at the login ID column, we notice we have those null values. So what we're going to say here is go ahead and grab where logins.log ID is null. And because the logins ID, that is from the right-hand table or table B, was null, this answers the question that these particular rows are exclusive to the left-hand.
So I think what has okay, if I do this film ID, I think this will be a better yeah, this would be a better, this would make sense a lot more. Where inventory is null, like right now we have a total of what, 42 entries where we can say that inventory is null. This is exclusive, like this is where it intersects the best. This is what I'm getting from this. So if I take this away, now how many entries do we have? Like I think we will have like 1,000 entries right now. Let's see. Yeah, we have 1,000 entries. Oh, there are more. Yeah, there are. Okay, there are more. But you get the idea, right? But when you do this, so what will happen if I where is null? If we do this, okay. So these are the movies that are not in our inventory. That's what that means. because this is a database of a DVD rental store, and so these are the movies that have came out, and these are the movies that we don't have in our inventory. That's what that means. Alice Fantasia. Okay, we got it. I got it. I don't know.
Table,
I got it.
or the registrations table. So Charlie and David can only be found in the registrations table. They cannot be found in the logins table. So this is a left outer join with an additional specification to only grab tables unique to the left-hand table. That is table A, or registrations, in this example. So definitely take your time with these, and feel free to watch this video a couple more times. Sometimes it takes students just a couple of times of watching this video to truly get the understanding of a left outer join. This is the most complicated join because it is a non-symmetrical join. So let's see some examples of a left outer join in PG Admin. If this is still a little fuzzy to you, I would highly recommend that you go back, watch this from the beginning, just let things cement theoretically, and then come with us and join some SQL.
If I understand this right, then the right join is going to be the same. Let's go with the challenges, right? Let's see if I can make a less of an idiot of myself than I was making previously. Let's see if my camera is right. Yeah, it's decent. You can't expect much.
Welcome back, everyone, to this lecture where we're going to challenge you and your new skills on the join concepts. It's just going to be 2 quick problems, but one of them is going to try to have you do something that we didn't exactly see in the lectures. So let's start with the first challenge, which is the easier of the 2. So let's imagine that a California sales tax law has changed, and we need to alert our customers to this through email. So the question is, what are the emails of the customers who live in California?
Okay. Select. Let's see. Select. I first need to know what is on all of it, right? From address. Address. I didn't know why I did that. I thought that it said something else. Sorry about that. City. California is a state, right? No, this can't be it either. Let's go with. Where the fuck is California?
Okay, here are the expected results. So you should be able to view 9.
It's district. Okay. Customer. Email. Yeah. Inner join customer on customer customer dot address ID is equal to address dot district district is equal to California. But Oh, sorry, sorry, sorry. Uh, like I said, I will make an idiot of myself every once in a while. Right now I did. Okay. Where